All right, I guess we start. I hope everyone can see my screen. I hope everyone can hear me well and see my screen properly. If not, shout out and I'll fix.
I can see half your screen. Half of it is black.
Half of it is black.
Yeah, same here.
Why?
Yep, half of it is black.
Okay, 1 second. I'll try to fix this. I am very sorry, technical problems apparently. How do I fix this? If I do, I'm gonna share like this. What can you see? Everything good?
Yes, everything good.
Perfect. Now. Perfect. Thank you very much. So we start. Thank you everyone for joining our webinar. The topic is integrating Kubernetes with a CERN monitoring stack, and it will be presented by me, Diana, and Guillermo. So let's talk about what we currently offer. So in terms of monitoring, we offer Prometheus stack, and in terms of logging, we offer FluentD. To create a cluster that has monitoring enabled is quite easy. You just have to provide the extra label monitoring enabled on cluster creation, and then you have all these components running on your cluster. So it's Prometheus, it's Grafana, it's Prometheus Alert Manager, and a few other components, and of course a node exporter that will actually export the metrics from your node. In terms of logging, if you want to have logging enabled on your cluster, you need to provide your producer and cluster creation. And this will ensure that you are connected to your producer and are sending logs as your producer. And you will have one pod for FluentD running on each of your nodes. We have certain configuration that we deploy by default for FluentD, which is filters, outputs, and sources, nothing too special or specific. And by just using the default configuration, you can see your logs from OpenSearch from the central thing, and all good, you can access them, you can filter. It's quite easy and nice, but at some point, many users asked for more flexibility from our setup, and we came up with this thing that we call user-defined configuration. So in addition to the default configuration, it is possible to pass a user-defined one. So you disable the default one completely, and you provide your own sources, filters, outputs. And this was very good. This is flexible enough to cover most of the use cases that we might encounter. But still, we were experiencing some issues with FluentD. For example, the FluentD buffer started filling up the disk on our nodes. We started trying to tweak the values of a FluentD buffer, but what was working for one use case was not working for another one. And as soon as the pattern of producing logs was a bit different, our setup was not working properly. And also when we tried to enable FluentD on a few of our clusters that have a lot of logs, we started experiencing issues and instabilities in terms of network on the clusters. So with all this in mind, and also after discussing with many of our users, we started considering moving to FluentBit instead. But we quickly realized that we don't have enough manpower available. So what can we do instead? Well, monitoring team to the rescue. With great observability comes great responsibility. That's why we are very happy to be able to collaborate with a monitoring team for this, because this way we can ensure that we have new features for metrics and for logs infrastructure in a timely manner for our users. We have very CERN-specific MONIT integrations installed by default on users' clusters, and we have experts that have a lot of domain knowledge in terms of metrics and logs and can help our users when we might not be able to do this as fast and as well as them. So with this, I decided to put this picture, the release of Prometheus. So the monitoring team came to rescue and release Prometheus from the Kubernetes team-induced torment. And just a small disclaimer, this is not available in the current release. We are still working and testing this properly. So follow the Kubernetes and the monitoring documentation and all our announcements to make sure that you don't miss this in the abundance of news that we have coming every day. And I put the links to the docs for both of our teams here. So the monitoring team is providing a very nice chart for metrics and logs, and maybe in the future traces. It's a very cool chart. We're still testing everything, but we hope in the next release or the one after, we will be able to deploy this as the default go-to solution for monitoring on our clusters. And I think with this, I give the stage to Guillermo.
Yep. Let me share the screen. Yeah, this text. Okay. Can you confirm that you can see the screen,
Yes,
please?
yes, all
Uh,
good.
Perfect. Good. So for those of you that you know me, I'm Guillermo from the monitoring team, and well, you can call me Willy. Almost everyone calls me Willy. So thank you very much, Diana, for this introduction about how it's working right now, the monitoring of Kubernetes. And what we would like to introduce is what can we do? What can we provide for the Kubernetes monitoring? Everything will be available, as Diana said, probably in the next release. So what we present today is basically a release candidate. And if you have any feedback, it will be very, very helpful. So, entering into the presentation, what do we offer? Basically, when you want to monitor, there are three things involved. There is the collection of the information, then you need to store the information somewhere, and finally, you need to be able to consume it, to be able to see that information or to put alarms to explode it. In order to collect the information, what we provide is a Helm chart that is valid both for metrics and for logs. And in both cases, in the metrics and in the logs, we're allowed to get information from the cluster components themselves, like for example, the Calico nodes that are running there, pods, sorry, that are running there, or the nodes itself, the control plane, whatever, but also from the application that I aside, the user workloads that are really important for us. Then one that metrics those logs are collected, we store it into our central infrastructure. And here we have, always, you already know, different policies. So for metrics, for example, the default retention period is 40 days, but also there is a volume rate that we can discuss if you need more, but it's a default one that is 150K data points in a 2-hour window that is sliding. For the logs, here we have 10 gigs by default of logs on 30 days. When you can see this asterisk is because actually at the beginning you probably get 3 days of logs, but we can discuss it. Of course, if your rate is not very big, if you are not sending all the debug logs, probably this can be increased. And finally, once your logs, your metrics are stored into your infrastructure, how you can consume it. So you can do it two ways. In case of metrics, is via Grafana. But in the case of the logs, it can be either Grafana, configuring the data source, or OpenSearch. Here in today's presentation, I will probably focus a little bit more on Grafana. It's what we can offer and I can show you. But of course, all the logs information is available in OpenSearch. There is our backend. So first thing first, this is like how to start with the Helm chart and the things that you need to work with it. First of all, you will need to request as a tenant. If you already have one because you've been playing, doing, for example, remote write to us, if you know that concept, you already have the tenant for it and you don't need anything else. Otherwise, is to request a tenant is as simple as creating a request in Snow. And things that are important or we need to provide to us in that request would be the tenant name. We are very bad with imagination. So if you can provide us the name, it's always helpful. Like for example, monitoring team is monitoring tenant. Swan team is Swan tenant. It's really simple. And as much information as you can. If you plan to send metrics, if you plan to send logs, if you plan to send both, because that way we can enable different flows for you. And then indicate any special request that you have at the beginning. Like, okay, guys, I was using, for example, I know InfluxDB, and this was my rate of metrics. That information is very, very useful for us. And same for the logs. Hey guys, I had my previous OpenSearch index with producing, I don't know, 2 gigs a day. This is also useful for us. So provide as much information as you can there. And we will reply to that. Maybe not within an hour, of course, but we will reply and we will give you a tenant name and a password. And this is all the data that you will need to send things to us, because in the Helm chart, the first thing you will configure is which is your name or your username and which is your password. And from there, everything is configured in the backend to use those credentials. So two disclaimers here, small them. A single tenant can be used with multiple clusters, and actually we recommend to use like a single tenant for your team. Monitoring team uses old monitoring tenant for all our clusters. But also important to remark that a single cluster can only send metrics to a single tenant. That means if you're sharing, for example, a cluster with, we think it's not that common to do it, but if you are sharing it and split it by namespace, we cannot do this. So this namespace will send to this tenant, and this other namespace will send to that other tenant. Just for you to know. So here I just put an example of a snow request of we highlighted information that would be really, really important for us. But I mean, given the context, we all work at CERN, we know how to submit our request. I will just skip it for sake of time, okay? And we dip into the components of the Helm chart itself. So as we were speaking before, the Helm chart is split into metrics and logs. And those two parts are completely independent. So you can enable the one for logs, or you can enable the one for metrics, or you can enable both of them, okay? For the metrics part, very similar to what Magnum was using in the past, what Magnum team was putting to monitor in the past, we're using Node Exporter to get the metrics from the nodes. Then to get metrics from the pods, jobs, and things like that, we use kubestate. Then we queried Kubernetes API for information about, for example, the control plane, which is the rate of 500 errors that is my control plane producing, which is important for you to know. And this is basically the different collectors that we have, okay? In order to get all this information together, what we are using is the Prometheus operator. The Prometheus operator is our collector agent, and we say basically collect metrics for all these components. But this also allows extensibility because the Prometheus operator is listening for any custom resource definition for any Kubernetes object, in this case, that the user declares, like, for example, a service monitor or pod monitor that indicates, hey, Prometheus, go every 5 seconds, every 10 seconds to this service, to the pods that match this expression, and get the metrics from them. So that way, the users, once they install the Helm chart, they can say, okay, now I have the application A, we'll see later an example, and I want to scrape metrics from it. So I declare a service monitor that goes to the service application A every 10 seconds and scrapes the metrics that it's exposing. Once those metrics are within our Prometheus, what we need to do is to move them from there to the Monit infrastructure. Previously, from Prometheus, we were using the remote write protocol. You probably know, and if you have been involved in sending metrics to us from Prometheus previously, this is the way that we were doing. Now we move to OpenTelemetry, and therefore we needed something that was able to speak OpenTelemetry protocol. In this case, is FluentBit, and FluentBit is just a forwarding agent. It gets the metrics from your Prometheus every X seconds and sends to our OpenTelemetry endpoints. What this means is that in the case of the remote write, was just a post to our backend storage. But with the with the FluentBit writing to OpenTelemetry, you're going through the whole monitoring infrastructure to our Kafka queues and to the different backends that we have. In the case of logs, it's, let's say, much simple, but not that much simple regarding or comparing to metrics, because there we only have one component, that is FluentBit. In this case, we are running it as a daemon set on every single node of your cluster, and it's getting the logs of every pod executing, but the logs that are producing it into the standard error and into the standard output. Once the logs are reached or consumed by that FluentBit, we use a filter from Kubernetes that allows us to enrich with information from the pod. So this log line has been written by this pod that corresponds to this deployment that it's on this cluster, for example, which allows you to filter the logs later on, either on Grafana or on OpenSearch. Okay, so we've seen the components, how or how it works under the hood, the different things that it has for metrics, for logs, but at some point you need to configure it. When we want to install it, we want to tune it a little bit. So here is basically the higher level of abstraction that we can get from the Monit chart, okay, Monit Kubernetes Helm chart, is the values. When you get a Helm chart, you configure it via the values. Things that you need to provide is the tenant information, as we said before, the name and the password. And then the Kubernetes cluster. Why the Kubernetes cluster needs to be put here? Because every method that we scrape from a cluster, we put an extra label in it. It's the origin, or this label here, KDS cluster name. That way, when you want to filter for metrics, it's very easy to say, hey, give me only the metrics from this cluster and not from anywhere else. So basically here, you can put the cluster name that you have declared in Magnum, or you can put whatever other name you can put you want. The other thing is that if in two clusters you put the same name, take into account that later when you visualize the metrics, they will seem like they are the same one. So by default, if you install the chart without just modifying the tenant section and the Kubernetes section, the metrics will be labeled. So every metric from your Kubernetes cluster components, from the nodes, control plane, Calico pods, things like that, they will be scraped. The user metrics, no, because those needs to be configured later. But the default ones, they will be enabled by default. For the logs, this is not the case. They are disabled, and they are disabled in two different levels. Just for now, is for security. Probably in the future, it will be just one level, but for the moment, it's two levels. So if you want to enable the logs, first thing in the logs, you need to say enable to true, but then you also need to enable the Fluentbit component. So it's deployed. If you just put this one to true, it won't take any effect. I said, this is for the moment, so follow documentation, follow updates, because probably this will change by the time that you are using it. Good. So let's try to install the Helm chart. Which components are required? So first of all, the Helm chart requires some CRDs, some custom resource definitions. In this case, most of them are from the Prometheus operator. And to install them is just Helm install the CRDs that they are installed in the registry.cern.ch, and then the version. The version matches the release version, the tag version that we have, GitLab. And then the namespace. We recommend to use the monitoring namespace, because that way, if at some point something fails, you can just grant us access to that namespace and the components running there without having to touch anything from your cluster. Once the CRDs are installed, we can install the chart, the monitoring chart itself. Here, when we installed, it's almost the same operation. Helm install your release, where is your chart, the version, but then we need to provide the values. And the custom values in this case, they're mandatory, because in them is where you will find the tenant username, the tenant password, and the Kubernetes name. So here's an example on how to install, for example, the version 1. And what is inside these my custom values.yaml is just the contents of the following box. In this case, the name of the team, there is the rocket science team, and the password, first one to arrive, and my development cluster that I was using these days. Once this is done, and if this tenant and this password is correct, everything will be deployed and configured so that we and the monitoring infrastructure get your data, and the data will be available in your tenant. Here, we are going to go a little bit deeper and see how can we customize the metrics and the logs later to get actually user workloads metrics. For example, I'm deploying my application. It's called my service, in this case, from Nginx, that we can say it's a workload also. And we want to get metrics from there. So in the chart, within the metrics section, after enabled it, well, it's enabled by default, you have another section that is the server, the Prometheus server that is installed. And inside the Prometheus service, by default, is an empty list, that is the service monitors list. Here, you can define as many service monitors as you want. During the installation time, this will generate the service monitor Prometheus operator object, and that will cause that the Prometheus, it's in this case 30 seconds, scrapes the Prometheus metrics endpoint of, in this case, is a service monitor of the service that lives in the Kubernetes system that has these labels. So basically, how do I select? Go to this namespace, any service that matches these labels, scrape it into these endpoints, and every 30 seconds in this case. This is during the installation time, but sometimes you already have your Prometheus, your Helm chart installed, and what you want to do is just add, because I added my new application, my new service backend, like in this example, and what I need is to create a new service monitor, not during installation time, but during running time in this case. So basically here our Prometheus is listening for any service monitor, host monitor, or Prometheus operator CRD that is defined in any namespace within your cluster. So whenever you define a Prometheus operator thingy, we found it and we configure the Prometheus to scrape, create a recording rule, an alert, wherever. Well, in this case, the alerts only relate to Grafana. So, of course, more information on how to work with this can be found in the Prometheus operator because we have followed what they do. So whenever you create an object, we scrape it, we will find it, and we will configure a Prometheus accordingly. So usually, like in this example, your service is made of, for example, a deployment.yaml that will make the deployment, then a service on top, and sometimes you even have an ingress to allow traffic to go in. So what we ask just is to add a new file. In this case, would be a service monitor, and this would be the description of the service monitor. Basically, you select, in this case, would be the service that has the name my service backend service, and it has no namespace, so it will go directly to any service that matches this in any namespace. And once it finds any service matching this name in any namespace, it's 5 seconds. It will go to the slash metrics and get the metrics that are there. It's like declaring a scrape policy, but in this case, you have this small service discovery at service level. And this is how we can customize metrics for user workloads. Once the metrics are within our infrastructure, the monitor infrastructure, the next point, of course, is how I visualize it. How can I see if the metrics are arriving correctly? And in this case, we are using Grafana. You know the central Grafana instance that we have. You can access it via monitgrafana.cern.ch. And of course, you will need an organization in Grafana to be able to add your dashboards or to your visualizations, whatever. If you don't have one, again, you can request one to us via Snow ticket. And once we are in Grafana, let's assume that you have your organization. What we have to do is to add the Prometheus data source that contains our data, the Prometheus data source that matches our tenant in the monitoring team. So you basically need to add the URL. It will be exactly the same for everyone. Monit from LTS is from long-term storage, .cern.ch/Prometheus. That goes here in the connection section. Then for authentication, you select basic authentication, and you put both your username and password, the ones that we provided within the ticket that we opened initially. And no other parameter needs to be set, because when you authenticate with the Earth team, for example, or Earth user, you will only get access to your tenant data. It automatically will translate under the hood for you. Good. So we have the data source. Next step is to create those awesome visualizations and alerts that we all like. So once I have my organization, I go, for example, imagine that it's empty, I go to the home with the dashboards, and I go to create a new dashboard. That will allow me to add visualizations. A visualization basically is one of the boxes where you can plot data. Then you select your data source here, in this case, the rocket science team data source, and then you can add your queries like simple. Like here, for example, where I'm showing the API request total, and I'm doing a rate, so it's the request per second. In this case, there are two queries. First one is for 200, second one is for 500. And with that, I could set alerts. We will see later. For example, here, the alert should be fine because my 500s are much, much, much bigger than my 200s. My service is basically failing. Good. And this is how, or until here, is devoted to metrics. Now we'll move to logs because, of course, once we notice that something is failing in our metrics, we want to know why. And usually that is much more helpful to go into the logs and see, oh, my backend is disconnected, or my primary storage is not reachable, or is producing timeouts. That helps us a lot to debug the problems. So when you enabled the logging component, as we saw before, log enable and Fluentbit also enable the true, we will get any log produced by any container running in your cluster. And by log, I mean standard output and a standard error. Okay. Of course, you have the chart, and this goes with the values of the chart. So you can customize whatever you want. You can customize the input instead of scraping like we do here, the containers log. You can scrape whatever you want. You can add multiple parsers. You can change this as you want. This is like the most standard way of getting the logs from Kubernetes. And of course, Here, as we are using Fluentbit as a script engine, and we have different filters, if one container wants one parser, another container wants a different parser, in the annotations, they can define with a Fluentbit annotation, hey, use the JSON parser, or hey, I'm Java application, use the Java parser. That can be defined. Our Fluentbits that are listening for those logs will take into account the parser that is declared by the pod. So, uh, it's the state we are getting every pod, every workload that you run, every log that is in the standard output or in the standard error, but you can customize it. By default, here is the three main components of the configuration. So the input, what we do is a tail of every log produced by a container on every node. Then we filter. This filter is the Kubernetes filter that basically what helps us is to enrich with Kubernetes, for example, logging, annotation. Well, annotations and labels in this case are disabled, but you can enable it if you want them. The fact they are disabled because they produce a lot of noise. And the output in this case would be to open telemetry. That's our endpoint. For UC valuable TLP endpoint, that is something that comes with a chart and will be substituted by the value. As said, you can change whatever you want here, but out of the box, it's configured to work with us. If you need to, for example, write not only to us, but you have a Loki that is working on your side, whatever, you can add more outputs to those logs. And once we have the logs, how can we visualize it? Here, I will focus on how to visualize them through Grafana. But of course, the storage of the logs is open source. And in this case, it's open source Timber private. So you can go there anytime and see your logs in your indexes as you have been doing now, for example, with other types of logs. So to do it from Grafana, of course, as we saw before, I'm going to skip it. You need a Grafana organization. Okay, once that is clear, basically it's add a new data source, and in this case, it's an open source data source. There, in the URL, you put the monit timber private /os, and for authentication is the basic authentication, and then the user password is exactly the same user and password we configured for you for the metrics. So you don't have to have different users or anything. With one user and password, you can access to both sides. And then here, you will need to put your index name. Don't worry, we will provide you, but usually it's OTLP logs and the tenant name in this case, and the time field date, the time. Once you have this configured, it's exactly the same steps that we did previously. You create the dashboard, then you add the visualization, you select the data source, and you add your queries. Here you have a small example of, for example, the logs produced by the Kubernetes clusters, and they are split by the total logs, and from those, how many are warnings and errors. And then a table where we can filter, for example, for the Kubernetes cluster, namespace, or pod. So, okay, we know now how the logs are collected, we know how to visualize the logs, but in the monitoring thing, the most important thing is that no one should be looking at the dashboards 24/7. The dashboards or the monitoring infrastructure should be alerting us. So how can we create alerts? In this case, we are going to recommend to use Grafana alerting. So you go into Grafana, basically, and you define there your alert rules. In this case, if your cluster is dying, you will notice because Grafana is the one evaluating those rules. If you have your rules executing within the cluster and your cluster basically dies or loses connection, you're not going to get any alarm because basically the alarm infrastructure is living within the cluster. That's why we want to move it to Grafana. So how to add an alert? Well, if you're familiar to Grafana, there's nothing to explain to you. Otherwise, basically you go to alerting and alert rules. There, like in this case, you put a name. This is an example of an alert that is meant to tell us if a node is suffering from memory pressure condition. So we select the data source where our metrics are. In the case, it's the same data source we had before with RSD team, and then we add the query. In this case, kube node status condition. If the condition is memory pressure and the status is true and the metric is bigger than 0, so this metric basically takes the value 1 when it's true, fire the alert. And this is a very simple rule, but helps us a lot because it tells us when our nodes are suffering memory condition, no more pods can be allocated to it. So it's time either to see if something went out of control or to scale up our clusters. Good. So we saw how the metrics are collected, how they are sent to us, and how you can visualize them. So here are just some takeaways of the presentation, and then I will show you just a couple of examples, nothing live, just a couple of dashboards, because with these we want, or together with the chart in the future, we want to provide also some generic dashboards for Kubernetes monitoring, so that you don't have to, okay, I have my metrics, but in every organization of Grafana, we have to repeat the same dashboard to monitor the Kubernetes cluster or the cron jobs or whatever. You have to repeat once and once and again. So our idea is to provide generic dashboards that provide you some insight about your clusters and cluster components that you can reuse. Those are the examples that I will show later. But first, the takeaways. The monitoring team, together with Kubernetes One, will provide a Helm chart that will be to monitor both the applications and the clusters themselves. Here you have the URL to the chart repository, and basically the releases are done via tags in the cluster repository that are later uploaded to the CERN registry hardware, basically. So it's a good way to follow the release change, just to go to repository. Oh, there's a new release. Right now is release candidate. So as the note says here, wait until stable release to use it. Okay, if you use a release candidate and it breaks, is expected for the moment. I'm sorry. Um, for the chart documentation is within the same repository in a folder is called docs, and basically guides you on how to install, how to personalize or customize the metrics, and the same for the logs. And always remember that you have a snow ticket to request support for us. It's not only when things fail, but also if you need support, we can do it via that way. Good. So once you installed your chart, how do we store the information, or which are our retention periods for metrics, 40 days or 150K data points in a 2-hour sliding window, and for logs, the 10 gig or 30 days with the asterisk that I missed here. Remember at the beginning, probably there will be 3 days. Once we both agree, okay, this is a polymorph logs we can deal with, we can extend to 30 days. And finally, for visualization of your metrics and logs, you can use Grafana for both of them, or you can go directly to OpenSearch for the logs part. With that, I finished the presentation, but I want to show you some of the dashboards that we have. Yes, Diana, I know. I was seeing this picture. I could not take my eyes out of it. So basically, for example, here's an example of a dashboard that we have here in the monitoring team that shows the status of every Kubernetes cluster that we have. So basically, this dashboard is already generic enough so that if you put tenant, for example, Swan, every cluster from Swan that is reporting using the Helm chart will appear here with all this data. And the same for any other. We also have one that we are working is more detailed about cluster itself. Of course, you can see empty spaces. This is a more work in progress one, but the idea is to provide also. Here we have another example where we are monitoring all the cron jobs that are running within a given cluster. So basically, you have the cron jobs and the jobs that are executed within it, how it lasted, when was the last execution. I have to mention here that this dashboard was an inspiration by Nacho Barrientos from also our section. He made it for Nile, for Kafka thing, and basically we copied. I have to mention it because he's probably around. But it's very useful because basically here you can see the alert of all your cron jobs directly. And again, this is exportable to any other organization that is using our chart, because basically here we'll show your clusters with the tag that we insert, the KNS cluster name. It will get that. And for the cron jobs is standard from monitoring. And the final thing I would like to show you is how the logs arrive to, for example, OpenSearch, like this case, not only to show Grafana, but to OpenSearch. So here, I don't know if you can see because the zoom on my screen might not be the best, but you can add filters like, for example, namespace. You can see which is the namespace, and then you can select a value. Like, for example, I know the obvious one is keep system, and that will show only values from the namespace keep system if this refreshes. Yes, it already refreshed. So you can go here and say, okay, it's an Nginx. Oops, sorry, slow OpenSearch. I have a warning from the controller on which node is this? Okay, the English controller is throwing a warning because something with the body. It helps you to debug any problem that you have. This is the goal. And this is all that I wanted to show you today. And with that, Diana, I think you can come back.
Yeah, I just wanted to make a note. You mentioned that it would be very good to deploy this chart in the monitoring namespace.
Yeah.
If this is installed as part of our chart, it would go to kubesystem.
Then we will change it.
We're just preparing mentally, preparing you for this. I had a question. So you said we can add alerts in Grafana.
Yes.
As far as I know, there are two ways that you can add alerts. One is if you just go in the UI, you click on things and you add your alert. Another one, I think, which is the more persistent one, if you add I think it's a config map with the definition of alert, so then it's persisted. If
Where?
we do this for some of our clusters, so when you have a Grafana instance running on your cluster, we have alerts basically as code. So then if a Grafana pod dies,
Yes.
the new one that comes will still have alerts. Do you have this type of persistent for the alerts in your
Yeah,
setup?
in this case, when you create an alert in the central instance of Grafana, all the configuration is backed up. We backed up Grafana, and we have different instances of Grafana. So there is not this thing of, okay, Grafana died, I need to raise it again, because we are running this Grafana for you. We are the maintainers of it, and basically we have measures in place, so that won't happen.
Perfect. Thank you.
Welcome.
Any questions?
Actually,
Yes,
I have
Antonio.
one. Antonio, go first.
Well, thank you both for the presentation. I have actually a couple of questions, so if you have a shorter one, maybe you want to go first.
Mine is very short.
Okay, so we'll go first and then.
All right, thanks, Antonio. So my question is this chart like a fork/extension from the Kubernetes stack chart? Because I didn't
No,
know
it's not. We started from scratch with
from
it.
scratch.
Basically, we went to what do we need, which are the things that we want to monitor and we think are important, and we went out from there.
All right. But it's based loosely on Kubernetes stack. It's not exactly the same.
Yes, exactly. For example, the Prometheus operator that we think it offers a lot of extensibility for users is very, very similar.
And now the exporter, I guess it's standard.
Yeah, no, the Sporter is the same. It's a standard for monitoring of nodes in Kubernetes systems.
Right. Cool. Thank you.
Welcome.
Go ahead, Antonio.
So, thanks. Was mostly for you, Guillermo, because we use a similar approach for our metrics in our Kubernetes cluster, use the Prometheus operator, but also we have both push gateway and alert
Yeah.
manager. I know that alert manager, I mean, you suggest Grafana, but sometimes it's good to have both because you can, if one of the two fails, you have at least a backup. So do you plan to have any support for these two other?
For today, actually today in the morning, we were having a discussion with another team here at CERN, and they were asking us about the push gateway. And we planned to add an optional flag to have deployed a push gateway in the cluster with something like monitoring push gateway, where you can push your things and we automatically scrape for it. So you don't need to configure that part. You just say, I need a push gateway. For the alert manager, it's still an internal discussion that we have. If you have the need for it and you think it's feasible, you can send us a note ticket just motivating, hey, we would like to have the alert manager because A, B, C, and C, and we will discuss if we see, okay, this is completely reasonable, we will go for
Okay.
it.
And
Otherwise, one thing we were discussing there is that anything that you need on top of the monitoring cluster, of course, you can also install it. I mean,
Yeah.
for the time being, you can use the monitoring cluster and install your own alert manager. In the future, if we provide it, you can remove your own installation.
Since we were always a beta tester for this Mimir, I guess we can combine this because I can configure your Helm chart to still remote write to my Mimir instance and keep it.
It's not even required because the Helm chart is always writing to Mimir now. So via the
Oh,
Open
okay.
Telemetry, it will write to Mimir. Mimir is the backend. I have not mentioned it, but it is the backend for the metrics.
Okay. Okay. Thanks a lot. And
Yeah,
last
would be
point.
removing the would be like removing the remote write that you have now and changing it by the normal flow.
Okay. Okay. Perfect. Well, I guess we maybe need to follow up because we were also in the process of moving from Fluentd to Fluentbit and would be extremely
Absolutely.
good for us to profit what you have done. So I will ping you. Thanks a lot for this.
No, more than welcome. for questions?
Don't see anything for now.
Yes, hi, this is Alex speaking.
Hi.
Can you hear me? I'm not
Yes,
sure.
yes,
Yes, I
we
think
can.
yes.
Thanks, Willy. A question for you. Do you collect the Kubernetes audit logs and the system logs as well, or do you plan to?
For the metrics or for the logs? Sorry, I did not
For
get
the
the
logs,
last
for
part.
the logs.
Yeah, for the logs, we are collecting any logs that is produced within the standard output and error. The only thing we are not collecting right now is the Kubernetes events. Those are not collected, but any log produced by anything within Kubernetes, we are getting it.
Yes, so my question was about the Kubernetes audit logs, which
No,
are
I don't think we
not
have those.
code output,
None. Yeah.
and the system logs, so the journal CTL.
No, those we are not
no.
getting them. No.
And do you plan to add this?
For the moment, we have not the request. Anyway, the inputs are configurable, so if a given user needs it, he can put them. They can put them into the configuration of the Helm chart when they install without any problem. But from our point of view, or at the moment, we did not find that request.
Okay, thank you.
Welcome.
Do you plan on supporting Fluentd Kubernetes events as well? I know there is a plugin.
The Kubernetes event, there is a plugin. I still haven't looked into it for the moment.
So
Right.
what we do for Kubernetes events, if it's useful, essentially we run, I think it's an upstream image that just collects, listens to the Kubernetes events and prints them on standard output. So then it goes into the
Exactly, basically.
The regular workflow.
Yeah.
It makes sense.
I think for the point that Alex made about the logs, about the API server itself from the journal, it's reasonable enough to add them like right now, but maybe with a filtering to not collect everything. And specifically for the audit log, it's possible to configure it to emit in the standard output of API server. This is what we did in the last release, that we added audit logs. So when you do journal in the API, you get the audit logs as well. But the filter can be selective and select them.
Yeah, it's an option of extension. I said here we tried is to make the most generic thing and allow a lot of flexibility and configuration. So if special cases appear, they can be configured. But if it's a case that goes over the special and it becomes generic, probably we will take into it. Anyone else? I don't see the chat, so I don't know if there are questions in the chat.
There are no questions in the chat.
Okay.
So thank you, Diana and Guillermo. I will stop recording and close the meeting then, because the meeting needs to end to start saving the recording and not lose it. And a note to everyone that we will host office hours immediately after this meeting. So if someone wants to join and ask questions about the release, feel free, so that we don't wait like 15 minutes and then join again.
Good. So thank you very much for having us here.
Thank you everyone for joining.